Not every device you care about can join Active Directory, but they still need strong identities. In this module, we'll see how NDES and SCEP create secure certificate channels for routers, firewalls, mobile devices, and other non-domain systems, extending your PKI well beyond traditional Windows endpoints. Traditional ADCS works best for domain-joined Windows machines. It relies on AD Trust, DCOM and RPC, group policy triggers, and targets servers and desktops that live inside your security boundary. Modern environments, though, are full of non-domain devices, routers, phones, Macs, and BYOD. NDES with SCEP closes that gap. It uses simple HTTP or HTTPS, works without domain membership, and protects enrollment with challenge passwords or one-time codes. The key idea: ADCS takes care of trusted Windows, NDES and SCEP extend your PKI to everything else. At the enterprise edge, the challenge is issuing certificates to devices that don't speak AD or group policy. Network gear needs TLS and IPsec, mobile devices get certificates through MDM, and headless or IoT appliances usually have minimal OS support. NDES addresses this by acting as a registration authority that exposes SCEP. Routers, phones, and IoT devices all request certificates using a simple HTTP-based protocol, while NDES enforces which templates they can use, and the CA still applies your central PKI policies. SCEP is essentially an automated way for a device to obtain a certificate without manual admin work. First, the device discovers the SCEP endpoint and pulls down the CA and RA certificates so it knows who to trust. Next, it generates its own key pair locally and builds a CSR. Then it submits that CSR together with a one-time challenge password. NDES validates the challenge, signs the request as an RA, sends it to the issuing CA, and relays the issued certificate back to the device. NDES sits between SC key-speaking devices and your Windows CA, acting as a registration authority proxy. Devices send SCEP requests over HTTP or HTTPS to an IIS endpoint, which is simply the web front door. Behind that, the NDES validation engine checks each request. Challenge password, template mapping, and policy rules. If everything checks out, NDES forwards a sanitized request to the issuing CA over DCOM or RPC using its dedicated RA certificates, then returns the issued certificate back to the device. Placing PKI components on the network is really about deciding how much risk you're willing to expose to your issuing CA. Edge devices and the internet should only ever talk to a hardened gateway over HTTPS. That gateway then talks to something like NDES in the DMZ. From there, a tightly controlled internal gateway reaches into the TNL zone, where your offline root and online issuing CA live. The core principle: issuing CA stay deep inside TNL, never directly reachable from untrusted or DMZ networks. Anytime you deploy NDES or another PKI conduit into your CA, assume it will be probed and attacked at every layer. At the perimeter, enforce a lockdown path from known MDM or device networks only, ideally fronted by a WAF. On the web tier, remove legacy protocols, enforce strong TLS and cipher suites, and use a dedicated SSL certificate. Run NDES in a dedicated app pool and service account with only the minimum CA permissions required. Finally, protect NDES RA keys with hardware or secure key storage, not software-only keys. In this modern pattern, Intune acts as the policy brain and traffic cop, while NDES is the cryptographic engine. Intune builds a SCEP profile, generates a one-time password, and pushes that secret to the device. The device never talks directly to the CA. It sends its SCEP request plus that OTP to NDES. The Intune connector validates the OTP with Intune, and only then allows NDES to pass a signed, trusted request to the CA. So authorization is driven by the cloud, while key operations remain on-prem. When you deploy NDES, think of it as a chain of trust. At the top, the issuing CA owns the root trust and the signing keys. Beneath that, you create dedicated SCEP templates for each use case with strict security and short lifetimes so compromised devices don't hurt you for long. NDES doesn't automatically discover those templates. You wire them up through registry mappings that bind templates to the MSCEP key. Finally, IIS exposes that configuration as an HTTP endpoint that clients call for enrollment. At enterprise scale, the load balancer becomes the single logical endpoint for all SCEP traffic. That means every NDES node behind it must behave identically, or clients will experience random, hard-to-reproduce failures. Treat the farm as one appliance, same registry configuration, same bound certificate templates, and the same SSL settings and server certificates on each node. Any drift breaks affinity and can corrupt transactions. Use configuration management, scripted builds, and strict change control to keep these nodes perfectly aligned over time. When SCEP enrollment fails, troubleshoot along clear branches. If clients see HTTP 401 or 403, you're almost always looking at web tier problems. IIS authentication, SPNs, or service account permissions to the NDES virtual directory. If you get template not supported by CA, verify that the template is published on the issuing CA and that its name and OID match the NDES registry mapping exactly. If CSR processing fails, validate the NDES RA certificate chain. And test DCOM and RPC connectivity from NDES to the issuing CA. Effective PKI operations depend on treating telemetry as a core design requirement, not an afterthought. Start with client reachability. Are devices actually hitting your endpoints and authenticating? IIS and edge logs will show 401 and 403 spikes that usually point to directory, certificate, or policy issues. Next, check PKI service health. Event logs should quickly reveal RA certificate problems or template mapping errors. Finally, watch downstream behavior. For NDES and Intune, track OTP validation and sync failures so you can correlate issues across the end-to-end flow. This blueprint pulls together everything you've seen about secure NDES design. Think in layers. At the edge, you protect a fragile enrollment protocol with firewalls, DMZ isolation, and a hardened, load-balanced NDES farm, so scaling never means exposing your CA. In the middle, Intune and the device handle OTP challenges, so humans never touch shared secrets. At the core, the tier near issuing CA stays locked away, reachable only through a tightly controlled conduit. Design, log, and automate each layer as if it's independently under attack.